No audio? It was all so good last week, it never lasts, does it? Oh, audio, we're back. Just as I said it was, yep, good. All right, I was just saying good morning. Hope you all started on the assignment. For those that didn't, please start on your assignment. Only a few weeks to go, and the next few weeks are quite hectic because of all the public holidays, which means that some classes are not going to be there, but you will be moved into other classes to kind of make up for it, especially in week 10, because we want you to be able to sit the prac exam, but really it's so that you can log into the exam environment to make sure that everything works and is ready for your actual final exam. Yeah, how's everyone feeling about the final exam? So excited. Stop using ChatGPT now. I'm going to put it out there. Because there is nothing in the exam except for your brain to help you get through it. I mean, and you get access to the lecture notes, but that's about it. So you need to be able to understand what that code is doing or how to write it. Please. All right. When are the public holidays? There are so many. John, I'm going to put you on the spot, even though 10 minutes ago I just told you when the public holidays are. It's like 17, 18, 19, 20 of April, and then 25th of April. Something like that. There's a lot happening. Okay, so when we left last week in week 7, it was all happening. We wrote some code. We were inserting some nodes into a linked list. I kept reiterating to you that whenever you write the code, you need to check if something works at the head of the list, at the tail of the list, in the middle of the list, an empty list. Now, who took that code that we wrote in the lecture, went home, and I said to you, play around with it? Who played around with the code? Hands up, anyone? Anyone? So, for the one person that played around with the code, did you find that the code maybe failed a few of those cases? Not enough playing with the code. That code would have failed at a few of those cases. I left some Easter eggs in there to see who was actually not blindly copying whatever I did. And there is some inefficient code in there as well. And so today we're going to start by seeing when it will break, and also to give you an idea of how to actually test your own code. So one thing about 1511 is that we are so kind in your first journey to programming that we give you these auto tests. And these auto tests are so nice because they do all the testing for you, so you don't have to think about what you should test with. This does not last as you keep moving through 151, after 1511. Actually, 1511 we're still nice. But as you keep moving through your CS degree, those die down, and you have to be able to test your own code and have to be able to understand what your code is doing. So please, please, please don't just auto-test everything. Please think about how to actually break your code, okay? That's the best part, right? Breaking your code is the best way to learn. That's when you actually start to understand what's going on. If everything just goes successfully, brute force, that doesn't always work so well. So there are auto tests in the exam. I'm just going to put it out there. Yay. Not for the last 2 questions, not that many, but for the first questions and the hurdles, they really do test everything quite extensively. So we're not just going to, you know, remove all the help, but just make sure you understand what's going on. Okay, I also thought today we could break up our code, which is getting really long and really messy, into a multi-file project, because the number of people on the forum that have asked how on earth to compile a multi-file project, even though we did it last week, has been worrying. Okay, so shall we do that first? Shall we break up the code to make it look neat and pretty? Come on, I know it's Monday morning. You've got to get with it. Week 8, you can pat an alpaca. Everything will be all right. It's stress less week, which is the most ironic time to put it in week 8. Oh my God. Everyone is really struggling. Okay, hands up who's over university by now. Yay! People are being honest. Yes, you came in here, you thought it'd be a party, and suddenly you're up every night writing assignments and you are over it, and I get that. A very short break is coming, and I mean so short, you're not even going to feel that you've had a break. So enjoy. I think the final exam timetable is also coming out today. Today is released today. Your exam timetable, you're going to find out when your exam is. It's already out? There was a provisional exam timetable that had a mistake in it. There is no way 1511 exam fits in one day, in one session. There's 2 sessions of the exam. And you're lucky it used to be 2 days, 4 sessions. So 2 sessions, you're either in the morning and the afternoon. So for those of you unlucky enough to have your maths exam in the morning, guess what? You're going to back that up with a 1511 exam in the afternoon. It's going to be, that's the roughest timetable I've ever seen. But maths also will let you go into other days. So just once their timetable comes out, just be wary to like switch things around so you're not giving yourself the most awful timetable I've ever seen. All right. Should we break it up into a multi-file? Yep. Let's do it. Okay, so first things first, let's make a little folder. Amazing, we now have a folder, and what I'm going to do is I'm going to move things around. Let's actually create the files, and then we can move them. Now I have a linked list.c, and I just want a linked list.h. Okay, so okay, so who remembers what will go inside our linked list.h? Who remembers in a multi-file what sits inside the header file? Yeah. Yep, all the prototypes and definitions. So let's see what we have in our linked list file. Okay, so in here we have our include, blah, 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 blah. We have our struct node definition. We'll talk about, actually, let's do it now. Where do you think that struct node definition will go? Oh, hard audience this morning. Yeah. Potentially, yeah. It could go in the header file, but in 1511, we're going to stick it not in the header file for now, okay? And I will explain why as we go. But it can go either way, right? So I was trying to get someone to say into the other file, and I was going to get really excited. Yes, it could go there, and it could go here. But for now, it's going to go. Okay, then let's copy all our definitions. It's just going to really wreck my vibe here because okay, so in our header file, we have our function prototypes. I'm going to get rid of this for now. And we will talk about that. Don't worry. Okay, so this is our header file for those of you playing along. And it will have the function prototypes. Oh my goodness. Any hash defines will also go in here, if you remember. I just don't have any hash defines right now. Okay, amazing. So what do I do now? Now I want an implementation file, yeah? So I'm going to, any implementation of these 4 functions that are sitting in the header file are now going to go into your linked list.c file, okay? And then everything else into the main file. So let's go, this is quite painful. I don't know why it's not opening multiple tabs. It's killing me right now. It's not what I wanted to do. Okay, so we've got our prototypes. I'm just going to take everything and move it into the other directory, and then we will break it up in there. Okay, oh, now it's doing it. Well done. Okay, so we've got our main.c. What's going to go into main.c? Oh my God, come on, people. Let's get some chocolates out. Everyone's having a crash, absolute crash of just, really, John? You're going to throw it from there? This is so much pressure. If you stuff it up, I will judge you. Just throw, yeah. More than, oh, look at that. That didn't even have to, yeah, wake up, off your phone. Oh, John, what a throw. What sport did you play? Don't throw the lollipops with the sticks. Maybe just those ones a bit of a more quiet distribution. Like the people behind you could have a lollipop. That was not a great throw. Oh, that was not bad. Yes, that was a good one. Oh, intercept. John. Still good, okay. All right, bit of a sugar rush. What should go in the main file? What do we reckon? I know it's so much pressure. You come to this lecture, you just want to chill out, and then I ask you stupid questions and you have to answer them. Yes, you raised your hand. Yeah, like the main function. It was like a stupid question that required a stupid answer. Okay, so we're in main.c, and everything in main, we can look at it later, but I'm just going to put it into my main. And then everything else is going to go into my implementation. So whatever was defined in my .h file, which is these 4 functions, they're going to go into my linked list.c. So I'm going to grab them. Here we are from this point on. And then I'm going to put them into my implementation file. All right, so now in the implementation file, I have those 4 functions that actually have the code associated with them. In the main, I just have a main function, which basically just calls out to the different functions that I have. So as you can see, there's not a lot else going on except for that. Amazing. So, and then my linked list.h is the header file that defines what functions I'm going to have. So I've got those 3 things. Let's save them all. And now, what do I compile? I've got 3 files. I've got .h and 2 .c files. What do I compile? Yes? Absolutely. I only ever compile the .c files because of why? Something that's not done in those .c files. How does it know to use that .h file? Right now it does not. Yeah. Exactly. I will include it in both of these files to show that I would like to use it. So before my, in my main, I'll include, and remember when it's my own, it's in double quotation marks, not miles. Clearly I want to be going away on holidays. And I'll include it in both .c files because they're both using those functions. Yeah.
How can we use the apostrophes for the quotation marks for our own files, but the greater than or equal signs for the others?
basically the greater than, less than, it's saying they're standard C library functions. They're not anything that I've defined or written. Whereas these ones are my own definition. And you can find them in this directory, basically, in the same directory. So when I do this hash include and say, okay, in my quotation marks, I have a header file. It's situated in the same place. What it will do is on compile time, it'll take whatever is sitting inside this .h and put it into your executable file right at the top. So we'll just compile it all together, because a machine doesn't care how long your file is or how messy it is, but a human does. Okay, excellent. Let's see if we can actually make it happen. Also, you have no access to anything here. So let me give you, okay, all those files should be visible now if you are looking at the code. Okay, so now let's compile. So DCC, we're going to compile main.c and we're going to compile linked list.c. So only C files get compiled. Okay, and we've got some issues. Let's see what our issues are. Invalid application of size-off, and it is happening inside one of our definite implementation files. Okay, why do you think it's having a problem with this situation here? What? Someone said something and I missed it. All right, what library do those things live in? Yeah, so they live in this library, and right now I'm using them, but I haven't actually included that library. Yeah? Okay, and what about here? Will it complain here? Let's see if it complains here. It might. I don't want to give too much away. Haha, okay. What's happening now? Did I not save it? It's because it's also in this library we have functions. Okay, both our standard libraries included, and let's try compiling again. Okay, great, good chat. Things are going so well for us today. I've included my libraries. Have I saved it? I've saved it, haven't I? Sanity check, saved? Yes. Oh, I know what's wrong. Okay, who can tell me what's wrong? This is what happens when you don't do things at once. When you decide later you're going to clean up. What do you reckon it's saying to me? Let's look at this error. Absolutely. I'm telling it to get the size of the node, but the node is not actually defined, right? The node is sitting inside somewhere else. Right now it is actually nowhere, okay? I don't have a definition for struct node because I commented it out, okay? So if it is sitting in here, I can still find it, but what I'm going to do is I'm going to take that struct node and I'm going to put it inside my implementation file, which is using the node. Okay, and the reason I'm doing this like this and not putting it inside .h file is it depends what I'm trying to achieve. If I put it in my .h file, usually with multi-file projects, I'll give the programmers that header file and they have to fit into the way I've defined the node. They can't add anything extra to it. They can't make anything happen. Whereas if I put it in my implementation file, I know that there is a node, but I define what the node has and what the node needs based on what code I'm writing. Okay, so let's try it again. We've got success, amazing. Okay, and now let's run it. Okay, a lot happening, terrible writing, which I can't remember from last week. We did have a mistake in there. I remember that now. It was inserting at the wrong position. We will talk about that in a second. But basically, we now have a multi-file. So we've split up our linked list into a multi-file project, okay? Which means it's much neater now to work with. I mean, debatable with this code, but it should be neater to work with. Okay, so let's talk about now what is wrong with the code that we wrote, and let's try and break it. So the first thing I'm going to do is I'm going to look at the insert at the tail function, okay? So create node, a few lines of code, print list seems all right. Let's do insert tail because it comes next. Okay, so I'm going to go to main and I'm going to call, so we've got print list, inserted tail, and then we've got all of that. So I'm going to get rid of this for now, comment it out, because all I want to do now is just look at that insert tail. Okay. And you know what I'm going to do? I'm going to put a new line there because it is really hard to discern what's going on because I've done it so messily. Okay, so after we do this list, what I'm going to do here is I'm going to print a new line. And the new line is just to make it easier for us to read what's happening. Okay, so I have a list. It's going to have the value 751 in it. Then I'm saying insert at the tail 11, okay? So it's using a non-empty list. And one of my cases, just a standard case. Let's see if it worked. So 751 and then 75111. So it works on a list that has something and I'm inserting at the tail. What else should I check? What are the like 3 things I always want to be checking? This is like easy peasy marks in the exam sometimes. If the list is empty. Amazing. Let's do that one. John, who was that? Chocolate, chocolate, chocolate. Wake up, wake up. Come on, Monday. Throwing needs some work. A combination. All right, so right now I've created a list. So what I'm going to do is I'm going to make that list empty. Yep. So when I've said struct node head is equal to null, it means that there is nothing in there, right? There's no list, and then I'm going to try to insert at the tail. So the first thing, the list is empty, and I'm going to insert at the tail where the tail should be the head. Yep. Okay, let's compile. Everything is great. Things are compiling beautifully. What happens when we actually try and do something? Okay, when we try and do something, what's happening is we're getting a runtime error. Now, this is the kind of errors that you get a lot with linked lists, and it means that you've mucked up something usually with memory. Well, in this case, with linked lists, usually with memory. And the DCC explanation saying you're using a pointer which is null, and you're trying to basically dereference a null pointer. And it's happening in this line of code here, whilst current next is not equal to null. And that's because if you have an empty list and the current is holding that null, and then I'm like, okay, dereference that current and see what's in next. Well, a null has nothing. So what I'm doing in here, right here, is I'm breaking because I'm trying to dereference a null pointer. So I'm trying to find out what's sitting in a memory address that doesn't exist, that's a segmentation fault in any other time. Okay, and you can see here the current is null, so when I try and do current next, I get nothing. Okay, so we've stuffed up a little bit of code because we forgot to take care of that amazing thing that checks whether or not you've got an empty list. Okay, so we need to take care of an empty list because right now it's not dealing with that edge case. So where do you think I would do it? Would I do it over here after the while loop? Would I do it before the while loop? Before? Excellent. I would indeed do it before the while loop because it's probably too late after the while loop. You're already going to dereference it. Okay, and what am I going to check here? What's going to be my condition that I check? If head is equal to null. Excellent. John? Sorry, John. Okay, so when I check if head is equal to null, I am checking first if the list is empty. Okay? Okay, and then what do I want to do if it's empty? I've created a node here. I've got this node floating about in space. Yeah. Absolutely. So I can just make the head the new node, right? Because that's all I'm doing. I mean, you could have like, yoo-hoo or something. I don't know. I mean, what a way to wake someone up. All right. Great. That should potentially do things, right? Should we try it? Exactly. So, yep. So right now, we're going to go in here. If head is equal to null, head is new node. And then I'm going to do a little bit of this. And am I going to encounter the same problem again? Yes, because who wants to see that happen? Or do you believe me? You believe me. Or you want to see it happen. You don't believe me. I mean, you shouldn't believe anything I say because I've just come in and said, guess what? I stuffed you up last week. I left you about 6 errors in the code and you should have looked at it and seen those errors. So, I don't know. The trust is broken. Okay, so let's have a look. Let's compile it again. So, did I save it? I saved it. Okay. Everything is great. Okay, everything compiles successfully. I'm on a winning streak. And then I'm going to run it. And nothing happens at all. That shouldn't have happened. Oh, it should have happened. Yes, it should have. Yes. Nothing has happened at all. Why did nothing happen? Yeah, it's because over here, my list is null. I've given it a new head. And then what happened? Then I went through, I returned that head, great. Here I've inserted at the tail, and then I printed the list. So what's missing? What do you reckon? I don't know why I enjoy this so much. This keeps me awake. Better keep you awake. Yeah. Yeah, so I've returned, I haven't returned anything. Whatever I've returned, well, I have returned the head, but I'm not storing the head in anything that I've returned. So I now have this new head, and I've returned it, but I haven't stored it. Here, I've just called the function. I've given it a node to make, and then I haven't stored my new head anywhere, which means that when it gets to this print list, it's just using the old address of head, which is null. Okay? Does that make sense? Yes, no, maybe? Yeah? So if I, it's not really going away. It really wants me to run an update. So I want to be able to store the address of the head because my head has changed, right? When I've inserted it at the end of the list, the new list, the new head is now the tail, it's the whole list. But my head has changed. Okay, so let's see what happens now. What has happened now? These are all the mistakes that you will have in your assignment. Anyone? 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 Got beautiful infinite loop here. Yeah, that will just not stop. But I'm going to stop it because there's only so much we can do. And where does that infinite loop happen? It happens over here and inside the print list. Okay, so let's have a look what we've done wrong in this code to make it behave like this. Okay, so you over here did point out that we could tidy this up a little bit. So when we're inserting at the tail, we're either inserting into an empty list or we're inserting into a list that already has some numbers in there. Yeah? So what we could do is we can create an else loop. I hate doing this as well because now my indentations are off. Okay, then I'm going to return the head, and then let's see also, let's see what happens now. Let's see if that works, okay? John, can you just run a poll whilst I'm, not chocolates this time, just letting you off the hook there, but if you can run a poll for me, please. Do we want to draw this code out to see what is actually happening? Okay, let's compile it. Let's run it. And this time we don't get stuck in an infinite loop. Yep. Okay, who knew why the infinite loop happened? Oh, you're making it hard. Yep.
Because while the current wasn't null, but it would increment, so as soon as the current became null, because the current was the next one, it was still just printing over and over again.
Yeah, yeah. Oh, that was an easy one, wasn't it? Could have even asked him what flavor he wanted. Come on, serve us with a smile. Okay, where's the poll? Here it is. Okay, 88% a resounding yes to draw it out. Okay. You guys just enjoy watching me draw things. All right, let's draw it. Oh, the one disappointing thing is, no, I can do this. Here we go. I want the code to be next to it. I want a complete mess here. Okay, so now it's harder to draw because I've got two functions, but let's just go in the insert tail function. Okay, so if you remember, the first thing I do here is I run this piece of code where I create the node with some data, and that data was the number 11. And here let's just start from main actually. Okay, so starting from main, I have the first bit of the function is saying struct node head is equal to null, which means that I am starting What is happening with my pens? You have got to be kidding me. Why is my pen not working? Pardon? You have a marker? That still doesn't solve my problem of why this is happening. Yep. Fine. Thank you kindly. All right. Oh, come on. Thank you.
Who's pushing them up here?
Who is pushing them up every time? Just leave it down. Okay, first line of code on line 24, struct node head is equal to null. That means right now I've got a fat lot of nothing. I've got an empty list and there is no node sitting in it. and it is my head. So this is the head of the list right now. It is a null, and the value of it is sitting inside the pointer variable head. Okay, the next thing I do is I am going to do this line here where I call the function insert tail and I say 11 head. So I am calling the function insert tail, and I'm calling it with the number 11, and I'm giving it the value of head, which right now is null, which means I'm sending it through with these values. Okay, we've called this function, which means we now go to this function and we have a look at this function over here. Just echoing myself, beautiful. Okay, great. We are now going into this function and we're on line 39, struct node, new node. We're creating a new node and we're going to call the function create node, data null. Okay, going up to do the function create node. So we've just called the function create node and we've given it data and null. So create node with the number 11 and with null. Okay, so then we go to line 15 and we say we want a variable, we want some space, we're going to malloc some space, size of a node, so I'm going to malloc some space and it's going to be the size of a node, and I'm going to call this space, store the address of this space in the pointer variable new node. Great, it's all empty, I need to fill it in with the values that I want. So new node data, so I'm dereferencing whatever this address is, going to new node, going into this data, and assigning it the value data, which I sent with my create node function. So I'm going to pop 11 in there. And then the next line, line 17, 16, I'm sorry, I have no depth perception from this angle. It's one of those lines. And then I go into new node next, so I dereference the next value, and I assign whatever value was sent to it. And the value was null, which means I am now assigning the value null to it. So I have a node now, and then I'm going to return it, I think. So the next line of code is where I return this new node. So going back to insert tail, and this result here is returning the new node and assigning it to new node. But remember, it's a different new node now. So I now have this new node. It's sitting empty, floating in space, but I do know where it is. So the first thing I do over here is I check if head is equal to null. Now I've sent my insert tail with a function. I've called the function insert tail and I've given it the head, which is null. So that if condition is true. It is null. There is nothing in that list. So if it's null, that means I go into this if statement and I say head is equal to new node. So what that means now is I want new node, the address of new node, to be the head. So that's no longer the head. This, can you see above there? You know, this board is still very tall for a small person. That's still head. So now that's the head, okay? So I now have this one node. It is now the head, and it's got the number 11 and null in it. Now, if I didn't have this else, right? So the first situation where we went into that loop that didn't break, okay? If I didn't have this, for example, so if it just did without this else, so I'll just delete it so we can see what it does. What I'll do next is I'll say struct node current is equal to head. So I'm saying my current is equal to head, okay? So it's equal to this node over here now, yeah? Next, I'm going to say while current next is not equal to null. If I dereference current next, I'll see that it is null, so that I will not go into that loop. But I will now go over here and I'll say current next is equal to new node. Yep, so I'll go into here, into this current next, and make it equal to new node, which is what? It's this node again. Yeah? And this is where I create this infinite loop because I'm using the new head of the list as opposed to my old list, which was null, right? Does that make sense? Yes, no, some nods, or some like absolutely does not make any sense. What is this rubbish? Like a little thumbs up. Come on, give me something. Anything? A little thumbs up, thank you. Okay. John, can you run an anonymous poll? Does it make sense? Why the someone in the chat is honest, doesn't make sense? Yeah. Pardon? You could. Yeah, that will work as well. Yeah. Yeah. That's okay, style-wise as well. Yeah. So there's always multiple ways to do everything in code, which is why reading someone else's code can be such a nightmare if they're thinking in a slightly different way to you. So what was said over here is if you in here return that new head, you leave this function, and that's fine as well. It means you don't do anything afterwards, and that works as well. Then you don't need the else, okay? Now I suggest you can also try to run through this code yourself. Yes, no, maybe? Maybe? Should we move to the next function, which has some more mistakes in it? Pardon? You're what? Oh, you're multitasking. That's okay. What was I after? Right now, nothing. That wasn't a question to you. That was a question to the students. I mean, you tell me to move on. You understand. You've sat through this lecture a few times, although it changes every time. Okay, let's shuffle along then. We can go back to it. A few people are saying, it's like, oh, it's yes and a little is winning the game. Okay, let's shuffle along to our next function, this insert at position function, which is really quite ugly. It's got quite a lot, sorry, not to make a function feel inadequate, but this function is not the best function I've ever seen. There's a lot happening in it. There's like an if condition here, an if condition here. There is like a bunch of stuff happening here. And if you remember from last week, it doesn't even work that well. Like it inserts the node, but not in the right place. So what do we feel? Did anyone look at why it does not insert the node at the right place? No? No one did? You did. And what, did you find the error?
I think so. I think we're supposed to stop when counter is equal to position -1.
Yep. That's one of the things. Yep. There's a few things, but yes, you're right. So you're going to be on a sugar high the whole day today. Okay. Should we fix that position first, or should we fix this awful like if statement and another if statement here, which is kind of like doing a similar thing? What do we think? What do we think? Come on, wake up. Just 5 more minutes before the break. Let's fix the 2 if statements, because that's a 5-minute job, not a, well, maybe, we'll see. If I run through the code, it'll be more. Okay, so I've got 2 if statements, and they don't fit on the screen at the same time, which is really, now they do. Okay, one of them is saying if position is equal to 0 and head is equal to null, so I've taken care of an empty list over here. And then the second one saying if position is equal to 0 and head is not equal to null, which is like that's just, it's got a list. I think I could do this in a nicer way. What do you think? Could I? Would you just trust me? A lot of trust in this room, yeah.
You could just nest the ifs. So you could have one that checks first if the position is 0, and then if the head is null, else.
I could do that, absolutely. So I could nest the if, so I could check if I insert at the head, and then I check if the list is null. Okay, that's one way to do it. Any other ideas? Thoughts? Nope, no thoughts. I understand. Week 8 is a hard time to have thoughts. Okay. Let's start by just checking if the list is empty. Okay?
I had an idea.
Yeah.
Sorry, I was a little slow.
No, that's all right. And you're right in front of me. I wouldn't even have seen you if you had your hand up.
So, yeah, I was thinking instead of like having to nest another long one into that, the only thing we nest is the what do you say, new node arrow next equal to new underscore node when the head is not null.
Yeah, yeah. Okay, so we could absolutely, yep. So let's do the first thing first. What happens if the list is empty? That means head is equal to null. We're going to take care of this case first just because it's always there. It's the most fun one to kind of think about. It also gives you like 1 mark in the exam maybe, even if you've got no idea what's going on, at least you've thought about what happens at the head of the list. So if head is equal to null, then the head is just going to be the new node. Spelled correctly, that would be helpful. Yeah, so what I've done is I've basically said if that list is empty, then my head is the new node. Okay, does that sound good? Everyone happy with that? That's it. I've got my new list. Amazing. We're going to run into the same problem again, yeah, if we don't have an else statement here. Does that make sense, why? That we just ran into before. Yeah, unless we return the head here. Okay, we could return the head in this if statement, but we're going to run into the same problem otherwise. So let's see if we do an else statement in here. So my conditions are if the list is empty, then I'm going to make the new thing happen where the head is the tail. But if my list is not empty, then I want to be doing something else. Yeah? And we will see what works and what doesn't in it. Okay, so I'm just going to make this code even messier by we will use some of this stuff. Okay, I'm going to take this part of it. Is that nice? I think that's nice. Okay, I haven't done anything yet though. I haven't inserted things. Okay. So I'm just commenting out some of the other code that we did to see what this new code does. So in the new code, we're going to create a node, and we're going to check if the head is null. So if the list is empty, we're going to make that new node the head of the list. Otherwise, we've assumed that there is something in the list, and we're going to go through it and have exactly the same problem again. But we're going to place it into the list at some point in time. Okay, what do we think? Try it out. Don't be scared to just run your code as well to try out what happens. Even if it's broken, it gives you at least something to work off. So let's compile it. It compiles okay, giving you a false sense of security. And then, well, it would really be helpful to call the function, I suppose. Let's call the function. Okay, so I'm going to insert a 42. Let's just insert it in the list for now, not at the head of the list. Okay, compile it again, and we're going to run it. And it has inserted it. Well, it's inserted a few 11s, and then it inserted a 42, so something's not quite right there. That's okay. gives us a nice, oh no, sorry, it printed the list the second time. So it's inserted it, but it inserted it, oh, at position 1. It actually worked. Okay. I mean, clearly I'm telling you it doesn't, that there is something wrong with that code. So let's try something else. Where else will I try to insert it? At the end? Pardon? At the tail, yeah, okay. So if I do, I don't know, let's do 2. And let's compile it. And let's run it again. Okay, so it really struggled as soon as, so again, I've got that runtime issue because I've dereferenced a null pointer, and that's because I tried to insert it at position 2. And it means that I kept going past the position. So my position was a lot higher than the number of things in my list. So that's something that we need to take care of. That's not being taken care of in this code. And and we will do it after the break, but let's do one more. Where else would I try? So we've done we've done the tail of the list. We've done past the tail of the list. We've done just normally in the list. One more thing to try.
Sorry, I have a question.
Yeah.
I'm a little confused. I mean, that error says you're accessing a pointer that is currently null, but if we go through the loop, because it's gone through the while statement already, technically isn't it non-null and it's just the next one that would be null? So I'm a little confused.
Okay, so here it's saying, so the current is actually null, and it's in here where I go current next. That's where I dereference it.
Sorry, that's where the issue is.
Yeah.
I thought it was inside the loop.
No, it's, yeah. Okay, so what else will I try? One more thing. Come on, live a little. Okay, where would I try to insert, like if I was testing my own code? So I've inserted a position in the list that exists, a position that doesn't exist in the list. What about at the beginning of the list, at the head of the list? Okay, one of the, yeah. So let's try it at the head. I'll compile it again. Let's run it. I mean, clearly I was leading you on this path of failure because it is going to fail again if my position is at the head of the list because I don't even take care of that, right? It doesn't work. So when let's have a break, then we'll like have a little brain decompress, and then we're going to go through the code and see why it doesn't work, which will also help with the other piece of code with the issues there, okay? And then we'll fix it. So let's have a little break, 5 minutes, and then we will come back. To kind of like someone saying linked lists are cooking them, just draw it, draw it, draw it. It's so, I promise. Yeah, a few people are confused. It will come together. It will. It's just between current next and current next and previous and who knows where else, it starts to get all a bit hectic. But if you draw it, it does come together. Draw it and run it as though you're the computer. Run through it line by line. You know what? Don't worry. I can see online, not looking forward to linked lists in the final exam. You've still got another 3 weeks, okay? Remember, you've just started linked lists. You can't expect to be, you know, across them straight away. That's not possible. I don't know if any of you have actually read the university stuff, how many hours you're meant to be putting into a per unit of credit. But by my calculations, a 6-credit course, you should be doing 15 hours of outside study. And I don't think anyone is doing 15 hours of outside study per subject. So just keep in mind that it takes time, it's not magic. Yeah. It's per week, yeah. It's like a full-time job plus another full-time job. So full-time job whilst you're hanging around uni, and then you go home and it's another full-time job. Good luck. It's not that bad, I promise. But what I'm saying is, it takes time and effort. You can't just, it's not, you know, you don't just get information just by magic. All right, let's start. Don't drop uni. Who's saying drop? Absolutely do not drop uni. It just takes time to transition to this new idea of studying. And no one is spoon feeding you. All the study is coming from you. Oh, you're killing me. Okay, so how do you correctly malloc? Remember, you've got to give it somewhere to store it. Then you've got to give it malloc size off and whatever it is that you want. If this managed update is not annoying everyone else, it's really annoying me. Yeah, it's killing me. But it's too late now. Yeah. What a great question. What a great question. This is, don't do work at 4 a.m. It's not a good time to do anything. For you guys, even if the 15 hours is not up, don't work at 3 a.m. Struct node star n, okay? But you can, yeah. Yes, there was a mistake there, so good luck, enjoy that. Whoever's saying yes, don't know, that's a good name. Next one. All right, here we go. New node to 99, new node data, new node 99. No, 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 no. Yep. Yep. Yep, beautiful. I mean, not good style, not good style. How is this one different to this one? Oh, you forgot. Yeah, you forgot the semicolon, which is a disaster when you're programming. Beautiful style for those 8 people, but well done. What other ones were there? No. No, remember new node is a pointer. It can't have a value in it. No. Okay, we're not inserting anything or calling okay, we just need to do a little bit more of that. Okay. Okay, who's at, is that 0 or an O? It's an O. Thank you. I hope it's just so exciting. Come on, please. I want to see 100% correction. Oh, I mean, that's very good, almost. So current is equal to current next, which is your best friend for assignment 2. This is, although for those that have said current next, I accept it. I understand what you were trying to do. But remember, you've got to assign the current the next node. Okay, head is equal, no, 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 no. Ooh, still winning. All right. Yay! So good. Okay, let's see what were the mistakes. Whilst current is equal to null, that's just saying one thing. That's whilst there is nothing in the list, so that's not going to work for us. Whilst head is not equal to null, remember we want to stay away from changing the head of the list just in case. So we place the value in head into current to move the list along. Whilst current is not equal to null, that's what helps us to move along until it is equal to null, so that the loop keeps going until we traverse all the way through the list. And whilst current next is equal to null, again, it's only going to check for that one condition. So you're going to be in a little bit of trouble when you don't reach it. Okay, we seem to have about 7 Kevins now. There's one in smaller letters, there's one with capitals, and there's one that's winning this Kahoot, who's apparently not the one on the chat for online students. It's like the Matrix in here. Oh, good luck, sorry. I keep forgetting how small. Oh, what is this? Sorry. I cannot hear you. Everything is really switched off. No, yeah, the only thing you have like access to is the website and DCC, just DCC. All right, 10 to 20, excellent. Oh, amazing. No one thought it was 10 to 10. 20 to 10, someone did the list backwards. And 20 people thought it would be a compile error, which it absolutely was not. The code was so good, it was proper. Probably those 2 lines at the end where they overlapped threw you off. Okay, great. Fake Kevin has been thrown off the throne. And next. So the question is, what would be the condition to stop at the last node and not at the very end of the list? Oh, okay, amazing. I'm very happy with this. Current next is not equal to null. Again, don't change the head. Whilst this, is equal to current. No, that's definitely not correct. Current is not equal to current next. No. And current, okay. We will do a few cases where we need to stop at the last node. No, the last question was how to get all the way past the list. This one is how to stop at the last node. Okay. Second last question. Well, we've had a few runtime errors today. You should be absolutely across this. Think back to when you were having a quick nap whilst I was talking in the first hour. What was it that caused those runtime errors? Okay. Line 19, if the argument to the function was an empty list. Where's the, here it is. Okay, so I've got current head, and remember this current next. Yeah, so if I have an empty list, then when I go into current next, I'm trying to dereference a null, which is dereference a memory location that has nothing in it. So this is going to cause an issue, which means I need an if condition somewhere at the top there that deals with the edge case if head is equal to null, so if the list is empty. So I hope if anything you leave this lecture with, it's the fact that an empty list will break you. So always check for it, okay? And update your computer, not during lecture time. Okay, next and last question. Thought we'd finish on a positive note. Oh my God, that was Freudian slip. Hey? Yeah. I'll balance the tree next as well. Yeah. Oh, amazing. Well done. Inserting a new data in a linked list, okay? I do not need to malloc anything if I'm printing a list. The memory is already there. I'm just printing it out. Updating the value of an existing node. If a node already exists, it's already been malloced. I don't need to do it again. And when you're deleting a node, you're actually getting rid of the memory that you've malloced, so which we will do tomorrow. Okay, let's see who has come top. ISO, number 3, number 2. John, get ready. AA, I hope that's absolutely amazing. That's what it stands for. And number 1, yes. Is anyone in this room from the winners? Not Kevin, number 7. John, yep. Whoever he hits, watch out. Oh, that was rough. That's one for the rats. Just throw a few more out in the audience. Why not? Nope. I think I really miss Bree.
Oh, sorry.
You're really struggling. Oh my God. You got to pick up the chocolate. There are rats in the building sometimes. John, you should really give people a warning. Everyone else is doing linked lists, and John's going to a camp to learn how to throw. All right, fantastic. So now the excitement continues, okay? I have said you're going to break this beautiful function, this insert function, and we're not going to know when you're going to break it. So what I'm going to do is I'm going to, oh no. Where's the, Let's see what it does right now and in which cases it will break, because that's the best way. Whatever code you have, don't worry about making the code perfect, okay? Just get some code on paper and then fix it based on what's happening when you run it. Same as an essay, right? Dribble first and then fix it. Oh, probably not good advice for an essay. I don't really know how to write good essays, so there we have it. Don't take my word for it. Okay, so we're going to go through this code and we're going to try and actually figure out what's wrong and what can we do to improve it. And we saw two things that happened that were broken, and one of those was if the position is going above what is already there. Then I saw in the chat what happens if the position is negative. We have not taken care of that. And there was something else that someone said that was spot on, and I can't remember what it was, but it was another issue with the code. Was it inserting at the head? No, I can't remember. Anyway, we will figure it out in a second. And this is the other thing. Whenever something is not working with a linked list, draw a diagram. It's cooking you because you're trying to keep what is current in your head, what is new node in your head, what is head in your node. Use a diagram, offload that onto a piece of paper. Okay, excellent. So over here, we are calling a function, and okay, to start with, if I'm inserting at the head, who can tell me what's wrong with this call to a function? Just as a quick, and you'll see it in a second. It's exactly what was wrong with line 33. If I've inserted at the head of the list, what's happened to that head of the list? It has changed, yeah. And if I haven't, I've returned the head, but if I haven't stored that head anyway, I'm going to lose it, and I'm just going to use the old head to print the list, okay? Which means that I'm going to stuff it up. I'm not going to put that in yet because I want you to see that that's a problem before before I just fix the code and you don't understand why it's a problem. So instead, we're just going to perform this, and apparently I'm inserting at position 0. I should have really inserted somewhere else. Doesn't matter. Let's go inserted position. So we're inserting at the head. So insert, we're calling the function insert at position. And the node has 42 in it, position 0, and I've given it the head of the list. Okay, let's see what the head of the list has. Oh, someone's using the bathroom. That's quite annoying. I can hear that, and that's bothering me. That's what happens when you can't filter noise very well. Good luck in the exam for those that can't filter noise. Okay, my list right now has one item in it. It's got the number 11. So the head, there is one node. And this is the head of the list right now from the last stuff we did. And it is 11, and it's pointing to null. Now I'm saying I would like to insert a node 42 at position 0, so that means I want it to go over here before my node number 11. Okay, so let's go back to our implementation file, and we'll try and do it. So line 64, struct node, new node. And I'm sending, does anyone need me to go to the create node function, or I've gone to it enough? I've gone to it enough? I think I've gone to it enough as well. So I'm creating this node, and this node has the data 42. And right now it's pointing to null. and the address of this node is sitting is stored inside the variable new node. Okay, so I've got new node, I've got the head of the list, things are going really good. Code is still working, nothing is broken. I come to line 73. If head is equal to null. Head is not equal to null. There is a node here and it's not null. So that means I skip over that if statement and I move into my else. When I move into the else, I say, okay, I'm going to have a current and the current is going to be whatever the head is equal to. So the current is now over here and it's pointing at the head of the list. Then I declare a variable called counter. This is how I get my steps up as well. Counter, and the counter is equal to 1. Okay, and then trying to highlight where I am at the code. I need where's Bree? I need Bree to do the highlighting, I think. Okay, here we go. So next is we've got our loop. Whilst current is not equal to null. Okay, current is not equal to null. Current's got something in it, so that part of the statement is correct. And counter is not equal to position. Okay, counter is equal to 1 and position is equal to 0. So they're not equal, right? Which means that while loop, everything is true. And that means I'm going to go into that loop and I'm going to do some stuff. But you can already see where we have broken it, yeah? Because is my counter, when I keep increasing it, is it ever going to be equal to position 0? No, it's never going to be. It's rough. It's never going to happen. So I'm going to increase counter by 1 and move the node to the next one. So I'm going to increase the counter by 1 on the next line of code. And I'm going to move the current to current next. And current next is right now null. So that means my current is now going to be over here. So when I check my condition again of the while loop, yeah, when I go back here to check my condition, while current is not equal to null, that's now false, which means I'm going to exit, not do this loop, and I'm going to go into here. And what I'm going to say is new node next. So this is my new node. The next is going to be equal to current next. And my current next is going to kill me because my current is null. So when I dereference current next, I'm going to have a runtime error because I'm dereferencing a null pointer. Yeah? Does that make sense? Yeah. Things are happening. Things are coming together, maybe. Okay, so we saw what the issue was. The issue is that I've gone past, right? I'm never going to have these two equal because I've started counting at 1, but my position is equal to 0. How could I fix it?
You can have independent if statements to check if the position is equals to 0. Then you just change the hat. You store the address of the input to the hat and make hat to the input next.
Yep, so I could do that. I could have another statement that checks if the position is 0, then I know I'm inserting at the head. Yep. I could try making that counter equal to 0. Do we think that will work? No. Hey? Let's see. So if I compile it, so it inserts it at the tail, not at the head. Every time, Daniel, you move the camera, I think you're raising your hand. I'm like, have you? And then I'm like, nope, he does not have a question. Okay, so we still have an issue here. It doesn't see that position. So, and why doesn't it? Who can tell me why that didn't work? So if it's 0 here and my position is 0, this is now, I just stopped explaining. I was like, does anyone else know? So this will be true, but over here I'll increase my counter and I'll move my current to next, won't I? Oh, sorry, yep. It won't, yeah. So I'm just going to have, yeah. Things are all happening here, okay? All right. So we need to fix some things, okay? We need to fix some stuff. It's not, so first of all, let's do what happens if that position is negative, okay? Just because if the position is negative, what does that mean? Or if the position is 0? I could make some things kind of combined together. I could do a separate if statement to check if the position is 0. I could do that as well. And that's perfectly legitimate code. Which way do you want to do it? Yeah. Okay. So things are pretty similar here. So what if I do this with good spelling? What if the position is, what do you expect the behavior to be if it's a negative position? Where will I insert it? At the head, right? Whatever, we're just going to make up this spec right now because that's going to be your life if you go out to industry, incomplete specs. Okay, so head is equal to now, position is less than 0. I'm going to say head is the new node. Is that going to work for me? Should we try it? Just try it. Okay, let's try it. And let's run it. Okay, so we've inserted absolutely nothing. Why haven't we inserted absolutely nothing? There is a reason for it. So head is now equal to the new node. And, okay, I've returned the head somewhere down there. I've captured the head, so what's happening? That's not the right place. I just gave it away. I should read. What happened? Yeah, I've lost that head, the new head, it's gone. I've returned it, but I haven't actually stored it anywhere. So this is still using the old head. Okay, what happens if I actually store the return of this function, which has returned the head? What if I store it inside my pointer and then I print the list with this new? Okay, and let's run it. Okay, so this is not, I really should have, sorry, let me do this because otherwise it's very confusing about what is actually happening. Okay, so the first one's inserting at the tail and the second one is trying to insert 42 at the head. So great, I do have 42 inserted at the head, but I've lost the rest of my list. Gone. Yeah, and that's because over here when I've taken care of this insertion at the head, I've said head is equal to new node, fantastic, but that's all I have. What am I missing? Yeah, so new node next is equal to, and where should I do it? Should I do it before this head? Should I do it afterwards? After. So you're saying I need to do new node next. Thank you very much. And why do I need to do it before? Yeah, because otherwise I'm just pointing to myself again, right? If I do it beforehand, because I've changed the head over here, so I need to do it beforehand. So let's see what happens now. Okay, amazing. So something is happening now, something where it's inserting it and everything is working okay. All right, so we've taken care of one thing. What else do we need to take care of? What else do we need to take care of now? What else do we need to try with this linked list which broke us last time? Yeah, position was out of this list and there was one more. Let's just try inserting it. Let's give a few more things. So we've got one thing in here. Let's do one more. I'll make a list of 2 items. and then we're going to print list, and then we're going to insert at position. So we've got the head working. We need to take care of the position that's gone beyond. So if I include at position 3 when there's only 2 things in the list, let's see what it does. Okay, it's going to break it. Yep. And why does it do that when we went through it? So if we're over here, okay, and my, let's say, counter is equal to 0 over here, and my position is equal to 3, and there's two things in the list right now, 11 and 13. What will happen is, okay, current is not equal to null. When it first checks, it'll go 0 and 3. Those are not equal, so I'm going to move it along. And the problem is going to happen when it tries to dereference because I've moved too far past the list, yeah? Because I'm going to meet this condition first. My current is going to be equal to null when I come out of the loop. Okay, so if we stop at the node before, will that fix it? Okay, amazing. It will fix it. Who knows why it fixed it, except for the person that suggested it? Yeah. Yeah, so basically, if I didn't have, John, wake up. So beforehand, right, when I had this current is equal to null, current is not equal to null. What happens here when I exited this loop is that either my current, just pretend that's, no, I'm going to fix it, it's annoying me. Either current is equal to null or counter is equal to position. Now I know, okay, that if my position is equal to 3, then my counter is not going to be, I'm going to reach the end of the list first, okay? So that means that when I come out here, if position is 3, that means my current is equal to null. And that means that when I try to dereference that null here, I'm going to have a bit of a problem. Whereas if I go to current next over here, that means when I come out here, I'm standing on the last node. No, I am standing on the last node. And there is a next, right? It's not a null pointer. John, can you run a poll just to see that it's, do you understand why? Or would you like for me to run through the, would you like for me to draw a diagram and run through it? Would you like for this torture to be over? Not yet. I've got 10 more minutes.
Yes, please.
The torture or the diagram? Thank you. Okay, I just needed one person to commit to the diagram. Let's do this one first. Okay, let's make it current is not equal to null so that you can see what happens. Okay. I wish I had someone that just a magic. Okay, so what have I got? I've got a list, and the list right now is 11, 13. And I've got a node over here that I would like to insert. The node is 42. And I would like to insert it at position 3. Okay, great. So I've got my current is equal to head. So this is the head. And now this also becomes the current node. Great, I'm ready to start running through it. My counter is equal to 0. So counter over here. And counter is 0 at this point in time. I go into the loop. Is current not equal to null? It's not, that's true. And is counter equal to position? Counter is 0, position is 3, they're not equal, so it is true. So I'm going to go into the while loop, and in the while loop my counter is going to increase by 1, it's now going to become 1, and my current is going to shift over to the next one. So my current will now go in here. And I'll check the while loop condition again. Is current not equal to null? It's not, that's true. And is my counter equal to position? So is 1 equal to 3? No, it's not. So again, that's true, and I'll go through again. This time counter is equal to 2, and my current has now shifted over by 1 again. So the current is now sitting over here on the null. Great. Great. I'll check the condition again. So is my current not equal to null? Current is equal to null, so that's no longer true. So I'm going to pop out of that loop, and I'm going to say new node next is equal to current next. I do the right side first, and when I try and access current next, I'm going to realize that there's nothing there. I'm trying to access a piece of memory that doesn't exist, and it's going to cause a runtime error. And I'm going to come out of this program. Now, what happens, it means I've gone to the end of the list and past the end of the list, which means I now have a null. And what happens if I stop at current next is not equal to null? Okay, so let's see what happens then. So now we're going to do the same thing. Okay, so we start again. Counter is equal to 0. I've got the same list, and my current gets assigned to the head of the list. So current is now sitting over here. Current next is not equal to null, so I'll check in here. Is this equal to null? No, it's not. I've got something happening afterwards. That's true. And 0 is not equal to 3, so that's true. So I'm going to go into the while loop, increase the counter by 1, and I'm going to move the current up by 1 node as well. So that's going to be my current now. And I'm going to check the condition again. Is current next equal to null? Yes, it is. Okay? So that condition is now true, which means I'm going to pop out of this loop. And now when I say, okay, new node next is equal to current next, what's sitting inside current next is null. So that's now going to be pointing to null, which is fine, because it is going to be, it's at the tail. It's going to be the last node. I want that. And the next one is going to be current next is going to be new node. So this one over here, instead of null, is now going to be pointing to this node here. And I've successfully taken care of that case. Yeah? So in some situations, and this will become more obvious tomorrow when we're deleting nodes, you want to be stopping at the last node in the linked list. So when you go to current next is not equal to null, it means that when you come out of that while loop, you're sitting on the last node of the list. You haven't gone past it. Whereas if you check for current is not equal to null, you will go past the end of the list and sitting at null. So that means you're checking every element in the list. Okay. Okay, someone's failing inserting between nodes. We haven't tried that. Why would we try something so obvious? Let's just do edge cases. Okay, so let's try and insert between 2 nodes. So we've got what, node 2? No, there's 2 nodes at position 1. Hey? That wasn't to me, someone was just speaking. Okay, so it's not doing it, yeah? It's inserting it at the tail yet again. And why is that? Someone's picked up the error in the chat. It's because counter is equal to 0, so I'm 1 behind, right? Does that make sense? You're just going to need to, because we've run out of time, really. We've only got 5 minutes. I could run through the coast, bless you, very quickly, but it might not. So I'm just going to fix it for a second. So let's say we make counter equal to 1, or you could have position -1. Depends how you think. And if we run it now, then it will insert it correctly. Yep. So there you go. Something to do before tomorrow is you can see why that is the case. And there's, yeah. How's that? Can you now poll, how does inserting into a list, into a linked list feel? How many things did we break today? Is there more things to break? I feel like there's nothing else left to break. Maybe there was. That's a chocolate for anyone that breaks something else. So tomorrow, we're going to do deleting. And deleting is, I think, more of a nightmare than inserting, just to give you a heads up. All right, I think everyone is cooked enough. I think it's time to finish. I look forward to seeing you tomorrow for deleting nodes. Good luck with the rest of the day.